When you turn on a light switch at home, you probably don't even think about the immense amount of infrastructure that is required to make the electrical grid work. Today, we're going to take a tour of that infrastructure and we're going to show you how it works, from where the power is generated and transmitted over long distances and it comes right into your home.
If you've ever been to a man-made lake or reservoir, like this one outside of Bryan, Texas, it was probably made for power generation. They're not in the way you think. Although some are hydroelectric, like this one, many others are used for combined cycle power generation.
The first stage works much like any other combustion process, generating power from burning fuel, like in your car's engine. But these plants have a second stage, where the waste heat from the combustion process is used to create steam, which runs a turbine to generate additional power.
These plants are about 60% efficient, as opposed to about 30% without the steam turbine. That's why many are located on lakes. They need all the water they can get to produce steam.
Once the power leaves the power plant, it comes here to the substation, the workhorse of the grid. Now you've probably driven by so many of these things you don't even notice them anymore, but they serve several very important functions on the grid. The first is to transform the voltage down from the high voltage coming from the generators down to a low voltage for distribution. But they also serve several other important functions, such as providing circuit breakers to isolate sections of the grid when there's a problem, as well as current transformers, which allow the utilities to monitor the load in that particular area.
So as you're driving along the road with miles of transmission line, occasionally you'll see these weird cylinders attached to them. So what these are, what you call capacitor banks, and what they do is counterbalance the inductive load that is induced from loads being attached to the transmission line. And so they do this by having the capacitive load, it evens it out so that you have a more real power load. On top of this, they smooth out the power whenever large loads are attached so that you do not have a spike in voltage or current which could cause damage to appliances.
As you're also driving on the highway, you might see voltage regulators in series with the line. They are essentially transformers with tap changers to adjust the voltage of the feeders. These are used because over long distances the voltage will drop, and these are used to compensate so that the voltage at the receiving end is what is expected from the sending end.
Substation. The power is then distributed throughout the city down these power lines. At some point though, the power lines will usually take the power underground and it will transport it to residential areas.
Now, if you live in a modern neighborhood that's been built in, say, the last 30 years, you probably don't see any overhead power lines. That's because all the power lines are underground. So instead of having transformers on the pole, the cylindrical gray ones you always see, you have green boxes that you probably have and your mother probably planted a shrub to try and hide it. But that's how the electricity gets all the way from the generating station, down the grid, through the transmission system, and into your home.
Fucking rings.